Hello everyone, and welcome to another video presentation courtesy of the University of North Texas Physics Department with the assistance of the Physics Demo Room. My name is Corey Nook, and I'll be assisting with today's demonstration on thermodynamics, in particular the second law of thermodynamics having to deal with entropy. So the second law of thermodynamics states that for an irreversible process, that the total entropy of the universe will always be greater than zero, and that for a reversible process, that the total change of entropy of the universe will be equal to zero. So now the question is well, how do we define entropy? Well, entropy is just denoted as S, and so we say the change in entropy as having to deal with the heat and its temperature. So this is the heat and temperature of the process. You can also think of entropy with the reversible and irreversible processes kind of like a little bit of chaos, or how do you structure, or how do you mix things together? So to kind of go over the difference between irreversible and reversible process is to look at two different situations having to deal with the same substance. So now if I was to take a piece of ice, melt it down, and freeze it again, that's an example of a reversible process. Is that all I'm doing is changing the temperature of it and its heat to give it to a different state, but it's still the exact same object as long as I don't lose any of its mass and lose any of the object as a whole. So just a change of state of an individual object without the loss of any of the mass of that object is a reversible state and a reversible process. Whereas now, if I just take a cup of water and I have some dye, and I now just put a drop or two in there, the dye now gets into the water and it'll mix around. And as you can see here clearly, it's going around everywhere. There is nothing I can do that will allow me to extract all that dye by itself. So that process is what would be called an irreversible process, because I can't take that dye out without doing a lot of work to the system as itself. And at least now a process that's somewhat natural to me with just applying heat and pressure. So this would be an example of an irreversible process, because I can't just literally reach in and get the dye back out. And I can't freeze it and get the dye out as well. Or I can't put too much temperature and have it get rid of the dye and come back. So that is an example of our second law of thermodynamics dealing with entropy. And thank you for watching this short video clip, and have a wonderful day.